Hello everybody, welcome back to Math with Allison. Today we're continuing our series on derivatives. If you haven't already, make sure to check out some of my previous videos. They're listed in the corner. You click that little I and it'll get you there. Otherwise, specifically, we're talking about the chain rule and how we can apply it. So let's just go ahead and dive into it. So the question of the day, when do we actually use chain rule? And it's when we have the composition of functions. So we have f of g of x. So an example of what that looks like is h of x right here. We have h of x is equal to 5x plus 4 all to the power of 100. Of course, we don't want to actually expand that out and factor it because that would take really long time, power to 100. So there's some rules that we can learn in order to take the derivative of this more nicely. So the chain rule here is where you take the derivative of the outside. So we have this f prime x at the inside. So g of x doesn't change at all. The inside stays perfectly the same. And then we multiply by the derivative of the inside, so the derivative of g of x. So let's go ahead and work this out in our example so we can see what it looks like. So there's multiple methods that we can use in order to solve this. I'm going to zoom in a little bit. Here we have h prime x is equal to, and we can just do the process. So let's go ahead and take the derivative of the outside. Our outside here is to the power of 100, and so I'm going to use power rule. I'm going to bring that 100 down, and now I have a power of 99. And remember, the inside stays totally the same. So here I get 5x plus 4. But now what we want to do is multiply by the derivative of the inside. So I'm going to multiply by the derivative of 5x plus 4, which is just 5. When I simplify this out, I'm going to multiply this 100 times 5. So I get 500 times 5x plus 4, all to the power of 99. So that's the way where it's just super straightforward. You just say it out loud or you do it in your head. There is another method that we can do here where we label the different parts. So what I'm going to do is take a variable u. My u is going to be whatever the inside is. So here I'm going to set this equal to 5x plus 4. And then I'm going to take g of u. G of u is whatever the outside is. So this is the inside to the power of 100. And what I'm going to do is I'm going to solve for the derivatives. So I get u prime is equal to 5, and g prime of u is equal to 100 u to the power of 99. And all we need to do is multiply these parts together. So if I were to find the actual derivative, I would have h prime of x is equal to u prime times g of u. So when I plug that in, I get 5 times 100. But remember, we're not going to use u because the original problem is in terms of x. So that's why I still need my u up here. I'm going to replace it. So I get 5x plus 4 to the power of 99. And when I multiply this out, I get 500 times 5x plus 4 all to the power of 99. So that's another method that you can use where you label the different parts and go through the process. But we arrive at the same answer either way, so whatever works for you is what you can do. Let's go ahead and see another example of this. So here we have h of x is equal to sine of 3x squared plus 4. So I'm going to go ahead and label my parts. My inside is going to be whatever is inside sine. So here I get 3x squared plus 4, which means now I can label my outside. So my g of u is going to be sine of the inside, which was just u. I'm going to go ahead and solve for my derivative. So u prime is equal to 6x, and then g prime of u is equal to cosine of u. And now in order to find our derivative, we just multiplied those two together. So h prime of x is equal to 6x times cosine, and not of u, I'm going to replace u back in, so 3x squared plus 4. And that's my derivative. Let's go ahead and try where we have chain rule multiple times. So first, my first set is my u is going to be x squared minus cosine of 3x. And my g of u is going to be u to the power of negative 4. It's going to be this exponent on the outside. So I'm going to find my g prime of u first, actually, and I'm going to use power rule. So I bring down that negative 4, and I subtract 1 from the exponent, so I get to the power of negative 5. And now u prime, we actually need to use chain rule again. So here I can take the derivative of x squared, and I get 2x minus, and let's go ahead and do this again. I'll use a different color. I'm going to say u is now equal to the inside, so 3x, and my g of u is going to be the outside, so cosine of u. When I plug this in, I get u prime is equal to 3, g prime of u is equal to negative sine of u. And this helps me find the derivative right here. So I'm going to get a positive, because I have a negative right here, 3 times sine of u, which was 3x. And so now I can go ahead and use these two parts, right, to find the actual derivative. So here I'm going to have y prime, since this is labeled y, is equal to, and now I just multiply those two parts together. So I get 2x plus 3 sine of 3x times negative 4. And remember, we've got to replace our u, so I have x squared minus cosine of 3x, and all of this to the power of negative 5. So sometimes, professors want us to simplify it out. Sometimes they're perfectly okay with this. I would say if I was the one grading, I would be okay with this, because who wants to FOIL that out? Let's be honest. So I'm just going to leave it as it is. If you want to continue solving, you can continue doing the algebra. It just depends on your teacher. Okay, so let's go ahead and use the product rule. So this is an application of product rule with chain rule embedded in it. So if we remember product rule, I have two functions. First, I have my e to the x, which is being multiplied by tangent of the square root of 2x plus 1. So I'm going to go ahead and label my parts real quick. Okay, let's find the derivative of f of x. So the derivative of e to the x is just e to the x. Doesn't change at all. But now we need to go ahead and use our little rule here for chain rule. So my outside is going to be tangent, and my inside is going to be this whole thing. Notice I changed it to the power of 1/2. That way I can see power rule happening a bit more. But I'm going to go ahead and substitute these in. So I'm going to say that u is equal to the inside, which is 2x plus 1 to the power of 1/2. And then my g of u is the outside. So that's going to be tangent of u. So I'm going to find g prime of u, which is equal to secant squared of u. If you don't remember that, you can check out my videos on trigonometry. Pretty great. And now, actually, we're going to use chain rule again. So I'm going to do it without writing out every single part. So I get u prime is equal to the derivative of the outside. So here I'm going to bring down the power. I'm going to bring down 1/2, and I'm going to subtract 1 from my exponent. So negative 1/2. So the derivative of the outside at the inside, so 2x plus 1. And we're going to multiply this by the derivative of the inside. Move that over real quick. So now I'm going to multiply it by the derivative of 2x plus 1, which is just 2. So here I get the 1/2 and the 2 divide out. And so all I'm left with is 2x plus 1 to the power of negative 1/2. So now I can go ahead and get my derivative of g of x. So g prime of x is equal to 2x plus 1 to the power of negative 1/2 times secant squared of u, but we got to replace u, which was 2x plus 1 to the 1/2. So now we can go ahead and apply product rule. If I do this, I'm going to start right here and multiply these two together. So f prime of x is equal to e to the x times, again, how much you need to simplify it out always depends on your teacher. So I'll simplify it out a little bit. I notice here I can pull an e to the x out of both of these. So I'm going to pull out an e to the x plus, and now I can bring this right here to the bottom since it has a negative exponent. So I get 2x plus 1 to the positive 1/2 divided by, and I would say that's pretty simplified at that point. So that's how we can use product rule with chain rule. Let's go ahead and try that again. Now we're going to use quotient rule with chain rule. So here I have my numerator is equal to e to the power of 6t, and then I have my denominator is 3t minus 1 to the power of 6. Let me go ahead and write those out. Alrighty, so let's go ahead and take these derivatives. If we don't remember, when we're trying to find the derivative of e to the 6t, I'm going to rewrite it over here. It's like a little triangle. So first we drop it down, e to the 6t, and then we multiply it by the derivative of whatever the exponent is. So here we're taking the derivative of 6t. This turns into 6, and we get 6 times e to the 6t. And so here I have my derivative. And now we need to find our other derivative. I'm again going to skip some steps, and I'm not going to write it out perfectly. So I'm just going to use it with words. I take my power and I drop it down. So I'm doing the derivative of the outside at the inside. Outside at the inside, and now I need to multiply this by the derivative of the inside. So the derivative of 3t minus 1 is just 3. I can simplify that a little bit, multiplying the 6 by the 3. I get 18 times 3t minus 1 to the power of 5. And so now we can go ahead and apply quotient rule. So here we get h prime of t is equal to, and now I multiply from top to bottom, all of this divided by the denominator squared. Alrighty, I'm going to go ahead and simplify this out a little bit. So I notice here I can take out a 3t minus 1 to the power of 5, and then I have my leftovers. And here I notice that I can divide out a little bit. So 5 of these can divide out. So 12 minus 5 is equal to 7. So when I rewrite this, I also notice that I have a e to the 6t in both of these. So if I'd like, I can pull that out. Again, it depends on how much your teacher wants you to simplify it. So e to the 6t, and then with my leftovers, I get 6 times 3t minus 1 minus 18 all over. We are almost done simplifying. I'm going to go ahead and simplify inside these parentheses. So I get e to the 6t times 18t minus 6 minus 18 all over 3t minus 1 to the power of 7. Once again, I can go ahead and combine. I'm just trying to get this as simplified as possible so we can see how much algebra goes into it. So I get minus 24. And all of this over 3t minus 1 to the power of 7. So I would say that's pretty dang simplified. You know, according to your teacher, they might want you to stop at any point during this. I try to simplify it as much as possible so we can see it, but who knows what you would need to do. But that's all I have for us today on chain rule. I hope you enjoyed this video. If you did, please leave a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.